is this is the apparatus. This is the crank and the slider apparatus, and this is the crank, and this is the slider, and this is the connecting rod. Select the desired crank and connecting rod, and then place the selected crank and connected rod to the crank holder and the slider holder. Once the crank set at a 0 degree, rotate the crank to 0 degree by rotating the turning knob, and the angle measurement can be redirecting from the protector provided. Record down the initial position of the connecting rod using the linear scale provided. The length of the crank and connecting rod is distance between the center of O. Slowly rotate the crank apparatus for every 30-degree increments, and then record the displacement value for the connecting rod. Take the reading up to the 360 degree. The displacement value is obtained by using the final value minus the initial value. And then for the last step, repeat the experiment using the different value of the crank radius and connecting rod's length. Hi, this is my D2 crank and slider experiment. My name is Dexter Wilson and Anthony, and for the result, this is the result that I get for the radius 5 centimeter. As we can see here, this is the graph between displacement and the angle. Okay, this is the first graph. This is the second graph, that is using the radius 3.8 centimeter, and this is the result when the graph is at the radius 2.5 centimeter. Okay, this is for the discussion. Explain how a crank and slider system work. This benchtop unit demonstrates the conversion of smooth rotary motion into the reciprocating motion. The input angle is set on a ball bearing mounted crank disc and read off an angle measuring scale integrated into the base plate, and the crank radius and connecting rod length can be both adjusted. Each have 3 positions. The simple insertion of a bolt enables the swiveling cylinder to be locked, and thus a crank drive with the either fixed or escalating cylinder can be demonstrated. Compare and discuss the result from the theoretical and experimental table. There will be a difference between the theoretical and experimental result because there are some error that will be occur due to the some external factor that might happen in this experiment. And that give you a comment or suggest at these 4 causes of error that may affect the result of the experiment. First is the instrument resolution, and then the second is the failure calibrate, and then error during the time taking. It is because take the time for a stopwatch might be delayed and causes error reading. And then human error by using the too much force while push the wheel. and then list some of the practical application of the crank and the slider mechanism. First is rotary engine, and then winch, and then hand pump, and then piston motion equation, and then the last one is reciprocating engine. For the conclusion is to study about the planar kinematic motion is successfully obtained, and then the second one is the study effect of changing of the connecting rod length is successfully obtained. For the safety, wear a safety glove and then keep distance from others. That's all for me. Thank you.